Autonomous driving technology is indeed another focus and battleground in the competition between China and the United States in the field of artificial intelligence. The application prospects of autonomous driving technology are extensive. It can be used not only in civilian sectors but also in military applications such as individual combat robots and unmanned vehicles, which are particularly urgent. It can be applied not only in autonomous driving but also in complex environment decision-making and the construction of large-scale simulated combat laboratories. Therefore, autonomous driving technology is not only an important area of strategic competition between China and the United States, but also a crucial technology support and a pathway to competing for dominance in military affairs in the future. This year, China's level for autonomous driving vehicles are accelerating their development and are expected to enter mass production in 2 to 3 years. Recently, Huawei's significant investment in the testing base for autonomous driving in Yangcheng Lake Peninsula was exposed online. This base includes 14 system laboratories, 103 static road elements, a dynamic control plaza with a diameter of 300 meters, and 3,000 typical traffic accident scenarios for basic testing. Through this base, Huawei can utilize the closed road environment to develop a vehicle intelligence plus vehicle road coordination technology route, allowing them to quickly obtain more comprehensive and better data and iterative algorithms. Ultimately, they aim to launch level for autonomous driving vehicles for urban open roads. However, to understand this issue clearly, we need to review the current status, bottlenecks, and racetracks in the field of autonomous driving. Autonomous driving is classified into 6 levels, L0 to L5, based on the degree of automation. Levels L0 to L3 involve human decision-making, while Level 4 represents high-level automation, and Level 5 signifies full automation where all operations are performed by the autonomous driving system. The difference lies in the fact that Level 4 can only be achieved in specific environments, while Level 5 can be achieved in any scenario. Currently, Level 4 autonomous driving faces four major barriers. Firstly, there is a computational power requirement of over 200 trillion operations per second. Autonomous vehicles require a high-performance intelligent computing platform, which serves as the brain of the vehicle. The most critical hardware component is the AI chip that provides computational support. The basic unit of computation power for AI chips is measured in TOPS, representing 10 trillion operations per second. Major players in the market for advanced autonomous driving chips include NVIDIA and Qualcomm. NVIDIA launched a 200 TOPS chip by the end of 2019, which has been provided to various automakers. Qualcomm also introduced autonomous driving chips that support Level 4. Currently, the computational power conditions are essentially met. Secondly, there is an algorithmic requirement of average takeover distance exceeding the average level of human drivers by 200,000 miles. Autonomous driving vehicles can only command trust if they are safer than human drivers. Statistics show that the average time for a non-fatal collision caused by a human driver is 200,000 miles. In other words, autonomous driving vehicles need to achieve an annual average takeover distance, MPI, of 200,000 miles, equivalent to the average level of human drivers. This forms a threshold for autonomous driving vehicles. On February 10 of this year, the California Department of Motor Vehicles released its full-year autonomous driving data for 2021. Calculating based on one of the key metrics, the miles per disengagement, MPD, the top 5 companies were AutoX, China; Cruise, USA; Didi Chuxing, China; Argo, USA; and WeRide, China. Thirdly, there is a data requirement of accumulating over 1.7 billion kilometers, approximately 11 billion miles, of testing data to achieve mass production of autonomous driving systems, as estimated by the RAND Corporation. Fourthly, there is a hardware requirement where the vehicle hardware needs to meet the standards. In addition to the computing platform, the vehicle's control system and other hardware aspects also need to meet certain standards. It is possible to develop Level 4 hardware without activating the autonomous driving functions, but the vehicle can be used for data collection, training, and testing. Once the conditions for autonomous driving are met, the vehicle can then enable true autonomous driving functionality through online software updates. Currently, what are the technological roots and bottlenecks in autonomous driving? As artificial intelligence comprises three core elements: data, algorithms, and computing power, competition in autonomous driving involves comprehensive competition in data, algorithms, and computing power. Given that there is no qualitative difference in computing power and algorithms at present, the competition primarily focuses on data. The key to big data lies not in its scale, but in the accuracy, dimensionality, and timeliness of the data. Therefore, based on different data dimensions and technological focuses, there are currently three specific technological routes in autonomous driving. 1. The single vehicle intelligent vision route. Represented by Tesla, this vision-centric approach relies solely on single-dimensional visual data. Such big data has its flaws, with the poorest data quality, requiring more powerful computing power to compensate for it. It is evident that algorithm breakthroughs are critical for Tesla. 2. The single vehicle intelligent LiDAR route. Represented by Google's LiDAR plus high-precision mapping approach, it involves data from visual dimension, LiDAR dimension, and millimeter wave radar dimension. LiDAR data has high quality and good timeliness, with greater accuracy, dimensionality, and timeliness compared to Tesla's data. The key breakthrough for Google lies in LiDAR technology. In terms of simulation testing data, Google developed the Carcraft autonomous driving simulation system as early as 2017, with 25,000 virtual vehicles running and testing 8 million miles every day. To date, they have completed 15 billion miles of autonomous driving simulation testing. Please note that the translation may not capture all nuances and technical details accurately. The third route is the vehicle road cooperative route. This approach involves multidimensional data from the vehicle as well as various sensors on the road, resulting in the highest quality and most comprehensive big data. Therefore, the vehicle road cooperative route is also the safest, with lower technological barriers and the lowest overall societal cost. It is evident that the key breakthrough lies in the intelligence of the road. The significance behind Huawei's automotive autonomous driving testing base is enormous. In other words, why is Huawei's R&D capability strong? Let's look at two successful practices in Huawei's digital transformation. 1 is the mobile phone drop simulation system. When developing mobile phones, Huawei initially used a mechanical hand for drop tests, which was inefficient and costly. Later, Huawei dismantled it into 11 dimensions and over 3,000 test cases, and used computer simulation to simulate the drop behavior. Now, all simulated drop results can be obtained in just 8 hours, saving time, effort, and money. Another is the 5G millimeter wave simulation system. Initially, Huawei collaborated with a foreign university on 5G millimeter wave technology. This university was globally leading in millimeter wave technology research, with a unique advantage of testing signal reflection, refraction, absorption, and penetration in complex urban building clusters, simulating real scenarios. Later, Huawei developed a 5G millimeter wave simulation testing platform and continuously modeled and optimized it. Now, Huawei's simulation system doesn't require a real urban environment, relying only on cloud computing and supercomputing centers to directly simulate high-definition 3D maps of complex urban environments, significantly accelerating the R&D process. It is this simulation system that has placed Huawei at the forefront of 5G millimeter wave research worldwide. From the above two successful practices, We can see that Huawei's establishment of simulation testing systems involves 3 steps, and the automotive autonomous driving testing base of Huawei may follow a similar approach. The first step involves conducting real driving experiments through 14 system laboratories, 103 road static elements, a 300-meter dynamic control square, and 3,000 typical traffic accident scenes to rapidly obtain raw big data from various real driving scenarios. The second step is to use this raw big data to feed algorithms through deep learning, establishing the initial autonomous driving simulation system. The third step involves continuous modeling and optimization to ultimately form a practical and effective autonomous driving simulation system. Please note that the translation may not capture all nuances and technical details accurately. Currently, Huawei's autonomous driving simulation testing system has accumulated over 5 million kilometers of test mileage per day. Last year, Huawei achieved 1,000 kilometers of autonomous driving without intervention, surpassing Tesla in capability. The computing platform's computing power has reached 400 TOPS. Huawei's comprehensive strength in autonomous driving, technology algorithms, computing power, and data is the strongest, and it is possible for them to take the lead in the future. Especially now that they have already overcome key challenges such as the cost of LiDAR and AI computing power. They are the most likely to emerge victorious in the autonomous driving race. However, ultimately, the winner will depend on who first surpasses a key benchmark, an average takeover mileage exceeding the average level of human drivers by 200,000 miles. It remains to be seen whether Google's rapid reduction in LiDAR costs or Huawei's optimization of road intelligence to enhance vehicle intelligence will be faster.